All right, so now we're starting lesson 3, water erosion, found on pages 22 to 31 in your textbooks. As usual, we're going to start with our connect it. So we have this image taking the plunge, figure 1. The powerful Niagara River plunges more than 50 meters from the highest point of Niagara Falls. Here, the hydrosphere, or the river, interacts with the geosphere, or the land, and shapes our surface. First, we're going to draw a line showing where Niagara Falls may have been in the past. And so we can kind of assume that the falls would have been up further. So how do you think Niagara Falls formed? And over time, the moving river water eroded some rocks faster than others on our surface. What do you think this waterfall and all other waterfalls have in common? And they are all formed from erosion by rivers. How water causes erosion. So first we have runoff. This is when moving water that picks up and carries sediment. There are 5 factors that affect runoff. 1 is the amount of rain in an area. The more rain causes more runoff. Vegetation. Fewer plants results in more runoff. Type of soil, shape of land. Steeper slopes cause more runoff. How people use the land. An example, pavement does not absorb water. That's why when we're driving, sometimes there is water on the pavement that's just standing there, and our cars do things like hydroplaning. Now, gravity causes runoff to form rills, gullies, and streams. Streams are channels in which water is continually flowing down a slope and rarely dry up. Tributaries are a stream of river that flows into a large river. This would be like the Missouri and Ohio rivers and being tributaries of the Mississippi. Sorry, I kind of lost my train of thought there. So, stream formation, figure 2. In the diagram, shade only the arrows that indicate the direction of runoff flow that causes erosion. So, that would be these 4 here, running down. Those are the ones that cause erosion. And how likely will the depth of the channel likely change with further erosion, and the depth will increase with further erosion. Reading check. Review the information in paragraph 2 and in figure 2. How does the amount of water change as it moves from rills and gullies to streams? And the amount of water increases as it moves from rills and gullies towards streams. Transportation of sediments. The speed of water depends on the slope and amount of water. As speed of water increases, the size of particles carried also increases. What part of the river in the picture has the greatest erosion happening? And that's going to be right at the edge there where the water is meeting the river at the bottom. All right, so here we have age of rivers. At A, we have young rivers. These are fast-flowing, V-shaped valleys, waterfalls, and rapids. With B, we have mature rivers, and these have less energy. They are slower. We have meanders and sandbars. So 1, where that is an example of a sandbar. With C, we have old rivers. They are very slow, shallow, large amounts of sediment deposited, many narrow channels, islands, and deltas. And number 2 is an example of delta marked on this diagram. Waterfalls. Figure 3, waterfalls form where rivers erode hard and soft rock layers at different rates. The rock at the top of the waterfall erodes at a slower rate than the rock below it. How do you think erosion will change this waterfall in the next 100 years? And the waterfall will move upstream as water continues to erode rock and layers. Water erosion and deposition. So water erosion removes particles on Earth's surface, and water deposition builds up Earth's surface. So water erosion features things like waterfalls. They're common where river passes over harder rock. Floodplains. That's a flat, wide area of land along a river. A meander is a loop-like bend in the course of a river. An oxbow lake is what remains of a river's former bend or meander. Water deposition and features are deltas. That's where sediment is deposited where a river flows into an ocean. And alluvial fans are a wide, loping deposit of sediment formed where a stream leaves a mountain range. So now we're going to do this, model it, an oxbow lake. So a meander may gradually form an oxbow lake. Draw steps 2 and 4 to show how an oxbow lake forms, then describe step 4. So at 1, we have a small obstacle which creates a slight bend in the river. As water erodes the outer edge, the bend becomes bigger, forming a meander. Deposition occurs along the inside bend of the river. So it's going to look something like this. Then gradually the meander becomes more curved, the river breaks through and takes a new course. And finally, the meander is cut off from the river. Reading check. What evidence supports the idea that a floodplain is formed by erosion and deposition? So a river spreads out and erodes the land, forming a river valley with a flat floodplain along the side. A river often covers its floodplain when it overflows and deposits sediment. Delta and alluvial fan. So figure 5. Draw arrows to show the direction to which water carries sediment to each landform. So in the top we have here, and in the bottom it goes downward. Record your observations about deltas and alluvial fans. So an alluvial fan forms where a stream flows out of a narrow mountain valley, while a delta forms where a river slows down as it flows into an ocean or lake. Modeling how a river changes Earth's surface, figure 6. This illustration is a model of a large area of Earth's surface. Circle the correct words in the labels to complete the sentences. Waterfalls and rapids. Waterfalls and rapids are common where the river passes over harder rock. A tributary. The river receives water and sediment from a tributary, a smaller river or stream that flows into it. Floodplain. A floodplain forms where the river's power of erosion widens its valley rather than deepening it. And an oxbow lake. An oxbow lake is a meander cut off from the river by deposition of sediment. Now we need to complete the 2 missing labels with types of landforms shown. Then summarize what you know about these 2 landforms. So we have a meander and a delta. So a meander forms when a river erodes the outer bank and deposits sediment on the inner bank of a curve. As a river approaches the ocean, it slows down and deposits sediment, forming a delta. Reading check. Use the illustration to explain how 2 different Earth systems interact to change the surface. So the river water, which is part of the hydrosphere, erodes sediment, which is part of the geosphere. The river eventually deposits the sediment to form a delta. The river wears down and builds up the land's surface along the course. Groundwater changes Earth's surface. So groundwater is the term geologists use for this underground water. Groundwater causes erosion by chemical weathering. This process gradually hollows out pockets in the rock. Over time, large underground holes, called caves or caverns, develop. Groundwater causes deposition. A deposit that hangs like an icicle from the roof of a cave is known as a stalactite. On the floor of the cave, a cone-shaped stalagmite builds up as water drops from the cave roof. So groundwater, erosion, and deposition. On the photo, draw a line from each label to the formation of its names. So for stalactite, as said previously, it's the top, and a stalagmite is the bottom. How do deposition and erosion shape caves? Outline your ideas in the table. And I have used another table for ours, so here we go. The process of erosion. So some water soaks into the ground, water fills cracks in rock layers, erosion by chemical weathering occurs. Water and carbon dioxide form carbonic acid, and carbonic acid breaks down limestone and forms pockets in rock. Then for the process of deposition, water with carbonic acid and calcium drips from cave roof. Carbon dioxide is released, and calcite deposits remain, forming stalactites and stalagmites. All right, so karst topography. If the roof of a cave collapses because of limestone erosion, the result is a depression called a sinkhole. This type of landscape is called karst topography. So how does groundwater cause karst topography? And groundwater erodes limestone in the ground to form deep caverns. After long periods of erosion, the caverns may cave to cause sinkholes. Karst topography, so figure 8. The sinkhole formed in a day in Winter Park, Florida in 1981. What was the cause of the sinkhole? And groundwater erosion caused this. So next we need to circle the state that has the most karst topography. And in that map of the United States, the one that is almost entirely covered with areas of karst topography is Florida. Next, we need to identify 2 states that have very little karst topography. And North Dakota and Massachusetts are both good answers for that. And that brings us to our Lesson 3 check. So number 1, what are 2 features that result from deposition by groundwater? And that's stalactites and stalagmites. How does a meander form by erosion and deposition? A meander forms when a river's movement erodes its outer bank. Over time, these processes cause the river to form a series of bends. 3. Identify and describe a landform that results from water wearing down Earth's surface. So near its source, a fast-moving river rapidly erodes the steep slopes it flows over, forming a deep V-shaped valley. How will Niagara Falls most likely change naturally in the future? An erosion of the rocks by river water will continue, causing the position of the falls along the river's course to change. Next, number 5, suggest 2 things a property owner could do to reduce water erosion on soil-covered land that has a steep slope. And the property owner can reduce the amount of runoff causing erosion by making the slope less steep or by planting more vegetation, or a combination of both. And that finishes Lesson 3.